Good day, class. You're welcome back to nursing 345 nursing research. We are on the 8th section. In this session, we'll be talking about quantitative research designs. In the previous session, we talked about qualitative research designs. In the previous discussions, we have explained that there are some of the problems that cannot be studied qualitatively. And so in this session, we will talk about the problems that will be studied or can be studied quantitatively. So by the end of this session, I expect each of you to be able to describe and explain experimental and quasi-experimental designs, and then differentiate between experimental and non-experimental designs. And so we'll be talking about three main areas: experimental designs, quasi-experimental designs, and then non-experimental designs. You can get this material from the two books, Chapter 9 of Foundation of Nursing Research, and then Chapter 9 of Creswell. So let's start with experimental designs. What are experimental designs? I want you to look at the picture and be able to form some kind of a mental image of what we are referring to as experimental designs. So these are designs in which one or more variable or variables must be manipulated so that you can measure the effect on the other variable. So the variable that is manipulated is the independent variable. The one that you are measuring the effect is the dependent variable. So the researcher is an active participant of experimental designs. Now let's look at the features of experimental designs or characteristics of experimental designs. There are three main characteristics of every experimental design. And these are manipulation. We mentioned in the definition that in experimental designs, something is manipulated. So one of the characteristics is manipulation. So this means that something is done to one of the groups. In every experimental design, we have the experimental group and then what we call the control group. So the experimental group is where the manipulation is done. Then we also have the control group. You do nothing to that group, so you can compare the outcome. The next characteristic is control. So the researcher holds constant the experimental situation in one group of participants. So for instance, if you want to measure the effect of music on academic performance among level 100 students, what this means is that you will divide these level 100 students into two. One group will be the experimental group, another group will be the control group. So you only allow the experimental group to listen to music. Then the control group will not listen to any music, and then you measure the effect on the two groups and be able to compare the outcome of the two groups. The next feature is randomization. I talked about the fact that you need to divide these students into two to manipulate one and not manipulate the other. You don't just decide that student A, you are in control, and student B, you are in treatment, or you are in experimental group. Randomization is what is used. So randomization is a process of giving every participant the chance of being part of any of the group. And so there's a way for you to randomly put the students in a group, and we will talk about that in another session. So these are the three key characteristics of every experimental design. Now let's look at the types of experimental designs. We have basic experimental designs and then what we call the Solomon 4 group design, factorial designs, repeated measures designs, and then randomized clinical designs. We will talk about each of them. Now let's talk about the basic experimental designs. These are designs that are less complicated because it has just one independent variable and one dependent variable. Types of basic designs. There are two main types of basic designs: after only or post-test only design, and then before, after, or pre-test, post-test designs. We will elaborate on each of them. Let's start with the first one, which is after only design. In this type of design, there is no data collection prior to the experiment. So let's take our minds back to the previous example that I gave. You have divided students of level 100 nursing students into two: experimental and then control groups. And you want to do a post-test only design. We're saying that data is only collected after the experimental treatment has been given. So let's say the experimental treatment is dance. You want to see how dance affects their academic performance. So you would not collect data. Collecting data here means that asking them to fill a questionnaire. So you would not ask them to fill a questionnaire before they do the dance. But after the two groups have done the dance, you will measure, or you would ask them to fill the questionnaire so that you can find out the effect of the dance after the effect of the dance on the two groups, so you can compare the findings. So here is an example, a very good example of an after test design or post-test only control group design. So here the randomization, which I described earlier, is done, which means that the researcher has used an independent way of assigning students to the two groups. And then you see the experimental treatment in the middle. And that means that, first of all, the experimental and then the control groups, didn't fill any questionnaire. Then you have given the treatment, which is the dance. After the dance, the two groups will fill the questionnaire. And then you do the analysis and find out the difference between the two: before, after, or pre-test, post-test design. This one is the opposite of the first one that we described. So here it means that you have two data collection points. You have divided the students into two. They would fill the questionnaire before they do the dance. So that questionnaire that they fill before they do the dance is called the baseline measure. After they do the dance, you would ask them to fill the same questionnaire again, and that is the outcome measure. And then you do the analysis and compare the findings. This is an example of what I just described. So random assignment to the groups, that is done. There's the pre-test, which means that they have answered the questionnaire. The treatment is given to one group, which is the experimental group, which could be the dance or the music, and then they fill out the questionnaire again. Now, Solomon 4-group design. This design consists of two experimental and two control groups. One experimental group and one control group will not be given the pre-test. And let's look at this example. So two experimental groups, two control groups. In this design, what it is saying is that one experimental group and one control group will do the pre-test. They will answer the questionnaire. And then all the four groups will be given the treatment, which is the dance or the music. After that, then all four groups will fill out the questionnaire, or they will answer the questionnaire. And then the data is analyzed and the findings are compared. The name Solomon is given because this guy was the first to come up with this design. And that's why it's called the Solomon 4-group design. Factorial design. This design involves multiple independent variables that are systematically manipulated in a single experiment. The previous one that we discussed, we have only one independent variable that is being manipulated. If you are doing a factorial design, it means you have 2 or more independent variables that you want to manipulate. And so let's see how that is done. In this picture, the independent variables that you want to manipulate here are different types of music. And so you have rock music, you have classical music, and you have no music at all. And so at the beginning, you have also divided them into the groups. Then you also have even the participants, you have categorized them. You have the young and old. So you want to see the effect of rock music on the young. You also want to see the effect of rock music on the old. You want to see the effect of classical music on young and old, and so on. And so if you are interested, so here we have 2 independent variables and 2 dependent variables involved here. And so the only design that you can use to do this kind of study is the factorial design. Repeated measures. This design is also known as the crossover design. And then I will soon explain what that means. It involves the exposure of the same participants to more than one experimental treatment. Now, the meaning of the crossover. You are exposing these participants to more than one experimental treatment. And so they can carry over the effect of the first treatment to the next treatment. And that's why it's called crossover or carryover effect. So if you look at this example, you have group 1, group 2 for the first session, and then you also have group 1, group 2. It is either the first one or the second one. Both of them are correct for repeated measures. So group 1 could be the experimental group, group 2 could be the control group. Pretest means that they will answer the questionnaire before you give the treatment. After they have answered the questionnaire, then you give the treatment, which is either the dance or music. Then you test them again, that is asking them to fill the same questionnaire again. And this is where the repeated, the carryover effect comes in. The questionnaire they filled for the pretest was the same. You gave them the same questionnaire after the treatment. Some of them may be able to remember the responses they have given for the first one, and so they will carry forward those responses and give you the same responses. And then after that, you give the second treatment. So here in this example, the first treatment could be the music, the second treatment could be the dance. And after that, you ask them to fill the same questionnaire again. So they are filling the same questionnaire 3 times, and so they can have a carryover effect. Now, randomized control trial or randomized clinical trials. These involve testing a clinical treatment or a clinical situation. This is a design that is often done or used when they are testing a new drug. And so, again, the participants are randomly assigned to the groups, experimental and control group. One group will be given the treatment, the other will not be given the treatment. In every clinical trial, you have several data collection points. You can have the baseline, which is the data that you collect before you give the treatment. You can decide to collect data again or ask them to fill out the questionnaire after 6 weeks. And then maybe after another 6 weeks, they will fill out again till you get to the end of the duration that you have put in the design. And so this is an example of a clinical trial. You start with a group of, participants. This picture is just telling you about how the participants are randomized into the groups. And I explained earlier that randomization means that you are giving every participant an opportunity to belong to either the treatment or the control group. And so these days there are softwares that can do that. And so the software is used to independently decide which participants goes to group A or group B before you start the study. Those were experimental designs. Now let's talk about quasi-experimental design. The word quasi is attached to experimental design because they are almost experimental design. Quasi means almost, so almost experimental designs, or in another way, they are experimental design, but one of the characteristics that we talked about is missing. And so if you look at this picture, it is a good example of an almost experimental design or a quasi-experimental design. There's nothing in this picture that is showing how they came by the people in the yellow box. How were they selected? We don't know, and then we will explain more of that in the next slide. So quasi-experimental designs usually involve manipulation of an independent variable but lacks randomization, which is a critical piece in experimental designs. The two groups exist. There is manipulation, but there is no randomization. There is no way of allowing the participants to belong to either groups. Maybe the researcher just put a line in the middle and say this is group 1, which is treatment, this is group 2, which is control. That is what makes it a quasi-experimental design. Now, this is an example of a classical quasi-experimental design. You start with the intervention group or the non-randomized assigned group. Non-randomized assigned group. That's what tells you that there is no randomization. But something is manipulated in one of the groups. And that thing that is manipulated is called the intervention. So, you are given a pre-intervention. Pre-intervention here means that they are filling out a questionnaire like we saw in the other examples. It's like a pre-test. Then you will give them the treatment, which is called the intervention, and then there will be a post-intervention. Types of quasi-experimental designs. We have non-equivalent, control group design, and then time series. I will explain each of them. Let's start with the first one, non-equivalent control group design. This involves an experimental treatment and 2 or more groups of participants. There is an experimental treatment, but the group of participants could be 2 or 3 or more. There is no randomization. The participants are just divided, I would say not scientifically. There is no way of deciding where each of them belong. And that is what makes it non-equivalent. Non-equivalent also means that maybe one group has 10 participants, the other group may have maybe about 12 or 15 participants. So something is not equal about the groups. So this is an example of non-equivalent control design. You have the experimental group and then control group. And I want you to remember that there is no randomization. So we have just divided them into groups. And then you have seen 0, 1 and then 0, 2, which is the pretest, which is signifying the pretest or the baseline data, or asking them to fill the questionnaire before they start the treatment. Now the treatment in this example is time. Maybe it is an examination situation. Okay, so they fill out the questionnaire, then you do something to time. Maybe you give some people 20 minutes, give some people, the first group 20 minutes, the second group 30 minutes. After the exam, they fill out the same questionnaire again, and then you compare the findings. Time series design. This one is a design that involves the collection of data over an extended period of time. It is also known as the interrupted time series. So probably you can use the semester period as the time period, the beginning of the semester and then the end of the semester. If you look at this, the picture on your screen, there is room painted in the middle. And there is the beginning of the curved line and then the end, and there is a dotted line in the middle. So in the beginning or at the beginning of the semester, if we want to know the room situation or to measure the room situation, the effect of the room situation or the lecture room situation to your learning, at the beginning of the semester, you come into the lecture room and the lecture room is the same as you know it. We will not tell you that we are doing a study. There's somewhere in the middle of the semester, you come in and then we have repainted the room, there are new curtains, everything in the room is new. And then you continue. We would make you fill out a questionnaire even before the painting. After we have painted the room, we make you fill out questionnaire again, and then we continue till the end of the semester. At the end of the semester, you fill out another questionnaire. And then we'll get to know, has the painting of the room done anything to your academic performance? So it's a kind of time series design. Now let's talk about non-experimental designs. What are these designs? So these designs have independent variables like the other ones, but they cannot be manipulated. And most nursing investigations are designed like that. You have an independent variable that cannot be manipulated. And the reason is because we deal with human beings, or nurses deal with human beings. So for instance, you cannot manipulate a human behavior. Some of them may be unethical. And because you cannot manipulate a human behavior, the only design that you may have to use is a non-experimental design. So manipulating human behavior, we talked about ethics earlier on in one of the sessions, is very unethical. Very, very unethical. And so this is the only design that you can use. These are some of the reasons why you must use a non-experimental design. If you have to manipulate a human behavior, no way. So non-experimental. Constraints such as lack of time makes experiments impossible. If you don't have enough time, like the example I gave previously, studying the effect of the painted room on your academic performance. It has to take the whole semester. If you don't have the time for that, you cannot choose that kind of design. The only way to go is non-experimental. Then experimental designs may not be appropriate for some other research apart from nursing research. Now let's look at the types of non-experimental designs that we have. We have the ex post facto or correlational design. Descriptive, surveys, evaluation, outcome, cross-sectional, and longitudinal. We will go through each of them. Ex post facto design or correlational design. Once you see the word correlational, what comes to mind is that you are interested in some kind of relationships. And so this design is used to conduct studies in which variations in the independent variable have occurred in the natural course of events. And then maybe you are interested in the relationship of certain variables. Then the only design for you to use will be the correlational design. Ex post facto, because maybe you are interested in a relationship of an event that has passed. The event has passed, but you are interested in the relationship of certain variables of that event. Descriptive designs is a very common design that most nurse researchers use, and this is about the most basic of the designs. And so the purpose is to describe something. The purpose is to describe an interest area or to describe a lived experience of a group of people. And so if you are interested in describing something, then you use the descriptive design. And this can be used quantitatively or qualitatively. Survey design. Again, when you see the word survey, what comes to mind is that you are interested in some kind of prevalence about something, incidence about something, distribution of certain variables, or the interrelationship between certain variables. And usually survey designs use large populations. And so if that is the crust of the research, then you have to do a survey design. And then the data is based on self-report. Self-report in the sense that you want the people to be able to fill out the questionnaire themselves. Nobody is reading out the question and interpreting for them. They are reading and filling it out themselves. And so survey data can be gathered through personal interviews, telephone interviews, or a questionnaire. Now let's talk about evaluation research, which is one of the non-experimental. This involves finding out how well a program or practice, procedure, or a policy is working. So for instance, if you are interested in how the policy on free, maternal health care or care you receive when you are pregnant, if you want to find out how that policy is working, it means you have to know a lot about that policy before its implementation, before you can evaluate the outcome on the people. And so the primary purpose is to assess the success or failure of something, which could be a policy. Outcome research is another non-experimental design used by nurses. And this is designed to investigate the effectiveness of an implemented program. So a program has been implemented, it has run for some years or months. You want to know whether it is working well or not. So you do outcome research, and that will give you either the good or bad sides of that project, and then you describe it as such. And so the primary purpose is to assess the quality of the program that has been implemented. Cross-sectional design. This one means that if you are doing a cross-sectional study, it means that you are collecting the data at one time. You are not going back to the participants to collect data. There are some designs you can collect data, or they will fill out the questionnaire. At some point, you go back again and collect data. Cross-sectional means that you contact the participants, they fill out the questionnaire, you take it away, and you are done with them. You don't go back to them. It's a very economical design. So longitudinal is the opposite of cross-sectional design. Longitudinal means that you want to collect data over a long period of time, and it could be a year, 5 years, or even 10 years. So you are interested in a phenomenon that demands that you collect data at certain stipulated periods of time. And so you use longitudinal data to study, longitudinal designs to study that kind of phenomenon. So in summary, this session has discussed experimental, quasi-experimental, non-experimental, and non-experimental designs. In the next session, we will discuss population and sampling. These are your references for further reading, and then I will see you in the next session.